Hi, I'm Vince Zobel.
And I'm Josh Franz.
We're group A13, and today we're going to be teaching you about truth tables. Alright, so what exactly is a truth table? A truth table lists out all the different propositional variables within a statement and all the different truth values for their outcomes within that statement. So Josh is going to write down truth tables for all the basics for you. First, we're going to start out with the negation proposition, and you're just going to use P and not P.
Okay, so to show the negation, first we start with the variables that we're using, which is just P to start. Okay, and then the outcomes, which is not P. So we have P and not P. The different possible. Then we have to list all the different possible combinations for the inputs for P, which, since it's Boolean, is only true or false. Now, we know from negation operator that if the negation of P is false if P is true. So we can write in false right there. And we know that the negation of P is true when P is false. We can write that there. That one is fairly simple.
Now on something harder. Let's do the conjunction. So we'll do P and Q.
So this time we have two different variables to deal with. So we have to still list our variables, P and Q. And then the result, which is P and Q. Now we have to list all different possible input combinations for P and Q, which is P is false while Q is false, P is false while Q is true, P is true while Q is false, and P is true while Q is true. Now we know that for the AND operator, the only time it is true is when both P and Q are true, which is right here. Other than that, it will be false. So we can look at this and say that it is false for everything else.
Alright, now on to the disjunction or the OR proposition.
The OR is very similar to the AND operator, the conjunction, except it's any time that that neither P nor Q is false. So in other words, the only time that P or Q is false is when both P and Q are false, which is right there. Other than that, we know that it'll be true because either P or Q is true.
Alright, just one more to cover the basics. We're going to do the implication.
As we know from class, implication, when P implies Q, is true always if P is false. So in the first two lines, P is false, so we know that the implication will be true. However, in the second two lines, it depends on what the value of Q is. For the last one, we know that if P is true and Q is true, then the implication is true. But the only time that an implication is false is when P is true and Q is false, which is right here. So that is the one time the implication is false.
Alright, so we're going to show you an example. Truth tables are a really good way to prove if something is a tautology. A tautology means that every possible outcome of the statement is true. So when you're using the truth table, you just want to make sure that in the last column where the outcome is, that everything will be a truth or a 1.
Right. So we have two variables in this one, P and Q. So let's list all the possible values of P and Q. Start with both of them being true. P is true while Q is false. P is false while Q is true, and both of them being false. All right. Now we can actually break up a truth table into multiple parts to make it easier for us. For instance, we have two distinct parts in this. We have P and Q, and P or Q. That's a lot easier than doing the entire thing at once. So let's look at these parts individually. P and Q. We know that P and Q was only true when P is true and Q is true, which is right here. Other than that, it will be false. So, we write in the truth table for P and Q. We also can write the truth table for P or Q in the same table, which is P or Q is true if P or Q is true, and that means it is only false when they are both false, which means these will all be true, just like we went over in the last section. Now that we broke it up into two separate parts, it's a lot easier to look at this statement as a whole. So, to look at the entire statement, which is P and Q implies P or Q, we can just use these individual statements to figure out if the implication is true. And as we know, if the premise is false, which is P and Q, then the statement will be true. So for these last three rows, we know that it will be true. And then for the last one, we look at it, and we see that P and Q is true, and P or Q is true. So that means it is true. That means that this implication is a tautology.
Alright, now for something a little bit more complex. We're going to do an example with 3 variables this time. With the added variable, it's even more essential that you break down the statement, and Josh is going to show you how to do that. This is also a tautology, by the way.
Okay, so we start with our 3 variables, P, Q, and R. So, first we had to list all the possible outcomes. I will just do R first, then Q, then P. True, false. Right. Move some stuff. So these are all the possible Q's, or R's rather, and then we'll list all the possible Q's. Note that we can do this in a sort of binary way. I did that wrong. That last one should be false.
Yeah.
This is the part we need to pay the most attention, because if you mess these up, then all of your truth tables will be wrong. Anyway, with these 8 statements, we can look at the first part, which is just P or Q. Then we'll look at the second part, not P or R, and then we'll talk about a third part after that. So for P or Q, we're just looking at this column and this column. I probably should erase this so it doesn't look like not. So, for Q, rather, wrong columns. I meant P or Q, not Q or R. Sorry, P or Q, like we said, is only false when both of them are false. So we can look down the list, and the only time they're both false is the last 2 lines. Other than that, they will be true. So, trying to keep my rows in line, which is not easy, I'm going to write in all my statements. Okay. Now, we'll look at the next one, which is not P or R. This one uses P or R. So, not P is just the negation of P. I could write another column for that, but to save space, I'm not going to. I just have to think about the only time that not P or R is false is when P is true and R is false. So, looking down the line, we have one of those right in the second line, and we have another one of them in the 4th line, but other than that, they will all be true. Okay, now we're going to take that entire first statement, this entire statement, and put it right here. Now, I don't want to write that in because it's a lot to write, but basically what we're going to do is take this column and use the AND operator on them, which, as we know, is when both of them are true. So we have true for the first line, then false, then true, then false, true, then true, false, then false. Alright, now we're going to stop and rearrange this table to be a little bit more readable.
3.
Okay, now I've rearranged the table so it's a little bit more readable. So now we need to worry about the second part, which is this part right here, Q or R. So we'll write that in, Q or R. try and draw a line. And we can look at just these two columns of Q and R. There we go. So, Q or R, as we've always looked at it, is only false when both Q and R are false, which we see right here and right here. Other than that, it'll be true. So we can just write those values in. Now, if we look at this last page, we have this statement right here implies this statement right here. So, which is the same as this column right here, this column, and this column right here. So, we can just write out the implies of those two columns. Now, the only time that it implies is false when the first part, the premise, is true, and the second part is false. So, if we look through, and also we need to write in, for whenever it's false, the premise is false, the statement is true. So we can write those in here, 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 and here. Now we look at the times when it's true. And we never see it being true, the premise being true while the conclusion is false. So that one, premise is true, conclusion is true. Same with this one, and this one. Now, since all of these are true, then we know that this is a tautology. And that is how you solve a little bit more complex of a logic problem with a truth table.